Egg-palettize. Egg-palettize. Everybody uses it. They don't even know it.
Yeah.
And some people even know how to use it.
A little bit.
There is a, it's actually a fairly important optimization to reduce the number of textures in the scene. There's a number of reasons it's a good idea. Let's see, if you have lots of different textures, well, okay, first off, egg-palettize. What it does is it's a tool for grouping together lots of little textures and putting them together onto a smaller number of larger textures. With the overall goal, basically just reducing the number of textures. And the reason that we want to reduce the number of textures is because there is, in some ways, a per texture cost for the things that we have in the scene. It's kind of so. There's a few things that are literally per texture cost. Each time we issue a graphics command to the graphics card, that's a change in state, and some graphics cards are more sensitive to this than others. So we can have fewer textures and issue fewer texture change commands. That's great, that's a win. Also, just in processing the scene graph, there's a certain number of texture chibs that we have to process as Panda is running through the scene graph looking for texture states. So if it has fewer different texture states to find, that's a win. But the biggest win is usually because when you have fewer textures, that means more of your geometry has the same texture state. And texture state tends to be the thing that most differentiates different vertices. And when things have the same state, then we can collapse them together into one geom and send them to the graphics card all at once. There's where our biggest win is. So the goal here is by reducing the number of textures, we theoretically reduce the number of geoms in the scene graph, whereas a geom is the atomic piece of geometry, a list of vertices that we can send to the graphics card in one call. And that's where the big win comes about. There are other wins. For instance, when we have lots of tiny little textures of all different sizes and we load them and unload them on the graphics card as needed, the graphics card memory can get fragmented. Just like a regular memory, if you do a lot of mallocs and frees, eventually your memory is going to get fragmented. If you're loading a bunch of textures that are all about the same size, this really helps because you're just loading the same big size textures over and over again, and graphics memory tends to be nice and clean that way. And that can help too in performance because as your graphics memory gets fragmented, then the graphics card the driver has to do more work to shell stuff around and really impede your performance. So for lots of good reasons, it's a good idea to have a handful of textures rather than thousands of tiny little textures. Of course, it's usually more convenient to paint in tiny little textures. But a lot of tools, especially nowadays, have facilities for managing this from the artist's point of view. Built into Maya, for instance, Maya makes it fairly easy for the artist to paint their little scene with little bits of textures here and here and here. The artist can arrange their textures on the palette as they like, and then they'll say, well, this part is really the face of my character, and he goes here, and this part is maybe the left leg. This part is the right leg, and here's the elbow, and the artist can put all this together however the artist sees fit, and that works pretty well. And this is what we would do if we didn't have egg-palettize. But this has a few limitations too. One problem is that once you've painted your palette, it's really hard to change it, particularly if you say, well, actually I'd like to have this texture right here be twice as big. And well, what are you going to do? You have to repaint the whole palette if you want to make this texture bigger. And that means you have to redo all the UVs on the model and everything. It's a big mess. So once you painted this palette, it's kind of static. So it's nice to have an automatic function that'll do this after the fact. And this is what egg-palettize does, where the artist can just paint these individual textures and leave them as individual textures. And egg-palettize will do this, examine all these textures and put them onto its own palette at texture build time, put them all in here, and it actually scrubs over the existing egg file and changes all the UVs in the egg file to correspond to the new UVs in the palette. And this is a much nicer system in several ways because first, as I mentioned before, it makes it much easier to change the size. We can suddenly change, days, months, even years after we've made this first model. We just suddenly change the size of this one texture to be something else, and the tool will automatically replace it in the palette, rework all the UVs, and everything just happens. Other things that are nice about it, this tool, the artist-based tool, is basically a model at a time tool. When the artist is painting one particular model, they'll work on one particular palette, and when they stop working on that and working on another model, they'll work on a different palette. And that works okay as long as you're working on just the textures within one model, which is mostly what you do anyway. But every once in a while, you might have some textures that get shared between some models. For instance, you might have a brick texture that happens to get used repeatedly, and it just gets used in this one little palette here, and then you want to use it in another model here, and maybe it ends up in a different part of that palette. Well, egg-palettize can recognize that potentially and put them all in the common palette that gets shared, which is kind of helpful. Yes and no. I mean, there are some advantages to having everything duplicated sometimes because you can more likely share vertices that way. But sometimes you want to share texture memory more than you want to share vertices, so it's nice to group those together into another block and then reference those two blocks together. The other big difference between this model and the egg-palettize model is who's doing the work of laying out the palettes. In this case, of course, it's the artist who's laying them out, and it's kind of good to give the artist lots of control. On the other hand, it's more work for the artist. In this one, theoretically, it's the tool that's doing the laying out. Of course, this also involves a heavy-handed programmer in there. The programmer has a lot of control over the individual sizes of the textures, the filter properties of the textures, all sorts of things that we have to decide for each of these textures. And the programmer is not necessarily the right person to make those kinds of decisions either. Then again, neither is the artist a lot of times. A lot of times we have textures that an artist thinks is very important, needs to be very large. But in practice, it turns out in the game they're actually very tiny and they can be half the size. And you don't really realize that until you get everything in there, and it's a programmer who does all that. So pros and cons either way. But on the whole, I think the big win of egg-palettize is the automatic resize and replace as textures are added and removed. Just do it, and boom, make install, come back the next day, and hey, all your palettes are new and better. Of course, it's the whole come back the next day is kind of a crummy thing too. Let's see. There are other implications of palletizing in general. Once we've put these textures in a palette like this, you can no longer do things that we might be used to doing when you have individual textures. For instance, you can't just do set texture. If you have this handful of individual textures and one of these happens to be your avatar's face, and you got the arm and the leg and all that stuff up here, suddenly you decide, well, maybe the avatar is having a bad mood and you want to give him a frowny face. Well, you can't just load up your frowny texture and find the head and do set texture on the frowny texture anymore, because now you've got this palette, and look at that, the face is in here inside this palette. If I loaded up the frowny face and put it on the part of the model that used to have his face, what I would see is probably just this part of his face in that piece, because that's what the palette has done. It's remapped the UVs to using this one little corner of this texture. And darn it, this texture is no longer that size. What can we do about that? In principle, we could have another palette standing by, which is exactly the same, except that it has a frowny face down in this little corner. Egg-palettize doesn't make that easy, and I'm not sure it's a good idea anyway. What we normally do in cases like this, where we really want to do this sort of thing, is we just omit these textures from the palette. We have to put a flag in the textures.txa file, which controls the egg-palettize, and says, don't put this one in the palette, and don't put this one in the palette. And that means that egg-palettize will put the rest of these in the palette, and it just leaves this guy out and leaves it as a loose texture. And that works okay. I mean, we don't get all the performance benefit anymore because now we have more loose textures, but it gives us some more control that we want. There are other things we have to keep in mind. When we have egg-palettize doing the placement of the textures, it tries to do a good job. It uses a basic greedy heuristic where it places first the largest textures into the palette, and then it starts to fill in the smaller textures as it goes, and then it starts to fill in the smaller textures yet, with the assumption that smaller textures are more likely to fill in little gaps. So that generally works in a pretty decent packing algorithm. But eventually you're going to come up with some texture that doesn't quite fit in the space you got remaining. Like maybe you got a vertical texture that doesn't quite fit here. And maybe if we'd planned it out better, we could have done a better job. And the human can sometimes do a better packing than the algorithm. So that's one strength of doing the artist packing. But on the whole, it's not so bad. It does a pretty decent job. Usually doesn't have too much wasted space. But it's going to be some wasted space, which is kind of a bummer. Because the wasted space is just pixels that we're loading up to the graphics card. They're just black. We're never going to render them. It's a bit of wasted memory. On the other hand, we're probably better off in the long run because we have less fragmentation, which is a big win on the graphics card. And sometimes we can actually end up saving texture memory this way because a lot of times, well, not a lot of times, but occasionally, the artist might paint a texture and only use some interior portion of the texture. And there might be some part of the texture that never gets used, never actually shows up in any polygons. Egg-palettize can actually recognize this, and it will map only the part of the texture that gets actually seen on any polygons into the palette. So this actually occasionally, very occasionally, ends up with a savings.
Does the Palletize automatically rotate vertical textures if it needs to?
It doesn't, but that's a enhancement we thought about adding. In practice, it turns out
not that important. I mean, artists can recognize that palette, and if something is to be rotated, they can just do it in the model.
Yeah, that's true. That's another. We have now the artists get more control over this than we used to. Back in the dark ages, when we didn't trust the artists at all, we just let them use a bunch of textures and we ran it through egg-palettize and that was that. But now we give the palettes back to the artists, they get to look at it and play around with it, and they can muck with the original textures that goes into it. In fact, Gita has written a tool that he showed me this afternoon, which is pretty handy. You can load up the textures that egg-palettize has produced, and you can point to the individual pieces of it, and it tells you what the textures came from and what the sizes are, and nice stuff like that. Really handy for artists. But yeah, and it probably happens very rarely that the artist needs to rotate a texture anyway, because in general we have a fairly good balance between horizontal and vertical textures. It tends to pack out pretty nicely. Let's see. The other thing to keep in mind with this technique of packing textures into a larger texture and remapping UVs, I mean, it seems like that's a great idea once you think about it, right? Because as far as you're concerned, the UVs just map onto the particular part of the texture that you're using. But the big texture, the problem that doesn't work with this is repeating textures, of course. If I drew this little brick texture, probably that wouldn't actually happen. If you have a brick wall, you're going to have a tiny little repeating texture that gets stretched across the brick wall many hundreds of times. Well, too bad for you, because clearly if you put a brick texture on a wall and say repeat, you can't repeat this palette texture anymore, because you're going to start repeating bricks and then left leg and right leg, and then bricks, left leg, right leg. It's going to look pretty funny. So if you have a texture that repeats massively, I'm sorry, it's going to have to be out of the palette. Egg-palettize recognizes this, and it will automatically omit any textures that seem to be repeating in the egg files. But there is actually a workaround that it can do if the texture is only repeating a little bit. For instance, it happens to repeat twice over a wall or something like that. Then egg-palettize can actually take that texture and duplicate it. Just duplicate it out of pixels and copy that duplicated pixels. So if you have a texture that gets repeated, for instance, 2 smiley faces side by side, it's really just 1 smiley face in the texture, but it happens to appear on a polygon where it's like twice. Well, we can just put both faces into the palette and reference UVs that way, and suddenly it's no longer a repeating texture. And that works. With the cost that now you've duplicated more pixels, and we're uploading to the graphics card pixels that don't necessarily need to be up there twice. But maybe it's a win in the long run anyway, because the other optimizations are still a plus. Egg-palettize has a parameter. It looks at how much of the texture needs to be repeated in order to put it in the palette, and you can set the threshold. I think the default's 3, something like that. Maybe we set it up to 4. So you could set it up. If we set it to 4, that means you could have as many as 4 smiley faces in a row, and we'd be happy with that. Or maybe your texture looks like this with a 4x4, and that also counts as a repeating of 4 times. And egg-palettize would just stamp out those 4 textures and be done with that. There are other limits. If a texture itself, original texture, is too large, it's going to fill up one whole palette image anyway. Well, might as well just omit that, because what's the point? And that's a threshold too. You can specify how large the palette images ought to be, and the proper size of your palettes depends on the age of the graphics card you're targeting, of course. Older graphics cards like smaller textures. Large or newer ones can handle much bigger textures. But that's basically the limitations as to what can and can't go into the palettes. Questions so far? Note that just by running your egg files through egg-palettize, you don't automatically get the benefit on fewer vertices, because it still gets loaded up into the scene through the egg file. But if you load up the model and then flatten it with either flat medium or flat and strong, then the flatten can be more efficient if the textures have been palletized, because there will be more geometry that shares the same textures. And flatten can only combine geometry that shares the same textures in another state. So in principle, since you'll probably be flattening anyway, once you load your scene if you're working for optimal scenes, you're going to load up your scene, call flatten medium or flatten strong on your artist, on your art. Flatten strong on your art, and that will reduce the vertices if you've already palletized things. Okay. So that's the high-level view, with a little bit of the low-level view thrown in for fun. Okay. Let's see. Egg-palettize does some other magic things along the way. It is capable of detecting the difference between a softly gradient texture and a cutout texture, like, for instance, a billboard tree, such as we have lots of these in Toontown, where this is all invisible alpha, and this is all solid alpha. Egg-palettize will recognize that most of these pixels are either 1 or 0 alpha, and it treats that as a special case because maybe you want to render those in a special mode. By default, if you don't do anything else, egg-palettize will flag these things with the mode M dual, which in Panda gives you the best quality view of a texture cutout like this. But it's not the best performance rendering of a cutout like this. In Pirates, we have that set to M binary. There's a parameter you can set to change that. And that means that it renders this without doing any blending. It's just either on or off, which is doesn't look quite as good, but works pretty well and is the most efficient you can do. If we didn't have egg-palettize recognize that, we would have to go in by hand and then identify all the cutout textures and make sure they had the right transparency set. So it's kind of handy that egg-palettize does that for us. It does other things. Let's see. A lot of times you'll have, we've found in the past, you might have artists that create an image called floor.rgb, and then later they import this into a file, some paint program that doesn't understand RGB, so they convert it to floor.tiff. And now I got floor.tiff and floor.rgb. It happened to be the same image. Well, egg-palettize is programmed currently to ignore the extension and just go by the base name and assume that anything with the same base name is the same image. This is good for collapsing together textures that are meant to be the same. It's bad when textures are not meant to be the same and happen to be given the same name. And this happens occasionally. In fact, floor is a terrible example because this is probably the most common unintentional name collision when we have an artist will make one scene with a marble floor and call that floor.rgb, and then some other artist will make another scene with a brick floor and call that one floor.rgb. And then somewhere else you'll have a concrete floor, and that'll be floor.rgb also. We've had this happen so many times with various different floors, it's not even funny. But on the other hand, at least we don't get accidentally redundant textures loaded up to the graphics card, which would happen if we had this thing going on. On the whole, I think we're probably better off collapsing together textures with the same name, because then it becomes visually obvious when a mistake is made. Whereas if we didn't collapse them and we kept them all separate, we'd probably never notice, and we'd just be wasting texture memory without even knowing it. So egg-palettize will collapse together all the textures that have the same name, even if they come from different directories, even if they're different models, they're created in different years, have different sizes. If they have the same name, it figures with the same texture. So it becomes an important thing for the artist to recognize that, and when the artist creates a very specific texture, they should give it a very specific name. If they're creating a very generic texture, they should give it an appropriately generic name. Yes?
So the texture.txt, if there's a floor.rgb and a floor.tiff, we'll just take one?
Yes, inside the textures.txa, it actually ignores the file name extension. You could call it floor.x. Doesn't matter. It just looks at the floor.
Really?
Yeah.
I had no idea.
I've seen edition where I've seen like floor RGB and floor TIFF. So does it just take one and ignores the other one?
I think it'll take the first one. So yeah, if you've got both of them in the same textures.txa, that's a mistake.
Does it give you a warning that you have floor.rgb and floor.tiff in your textures.txt?
No, I probably should.
Okay.
Aren't those textures transformed to RGBs anyways? Like later?
That's another parameter. That's another thing that egg-palettize does, is it optionally converts all the textures to the same output format, which is handy for when we download our client. We convert everything to JPEG, which is nice because JPEG is very tiny, saves a lot of space in the download, and also means that we only have to support JPEG on the published client. We don't have to support PNG and TIFF and all these crazy things that require a slightly bigger client build. You can specify that in the parameter. What kind of file format do you want egg-palettize to convert everything to?
The JPEG doesn't support alpha.
Right, and that's the other thing that egg-palettize does, is it can split 4-channel images into 2 separate images, an alpha image and a color image. For both Pyrus and Toontime, we have to do that. So it actually would output, in this case, assuming this is an alpha image with 4 channels, it'd create floor.jpg, and it would create floor_a.rgb. And the reason we use .rgb for the alpha instead of .jpg, just because RGB is a lossless file format, and you can sort of see JPEG artifacts in the alpha channel. It's a little disturbing. So we prefer to use RGB, which is lossless, but it's also run length encoded, run length compressed, which does pretty well for most kinds of alpha files.
What does that mean?
It is compressed in a linear list of number of pixels. So there's a number of 1 pixels. It just says there's 27 1 pixels, and then it says there's 57 0 pixels. And since a lot of alpha channels are bitmasked on and off, it run length encodes really well.
Cool.
Of course, it does a terrible job on gradients, but yeah.
So don't do gradients.
Yeah.
Gradient alphas.
Well, the gradients, we have like a cutout limit, sort of like if it's, we can specify the intention TXA, like if something is more than 0.3, make it 0. And beyond, make it 1. So it works out pretty good.
That's true, too.
Gets worse with texture compression.
That's true, but texture compression happens on the graphics card. It isn't related to the download.
Yeah. But your end quality is worse.
Yeah, that's true. So when we turn on texture compression, you start to see artifacts in the alpha channel, even though we downloaded a lossless image. Yeah. Oh well, what do you do? Let's see. Another handy thing that egg-palettize does is it allows us to centralize the place where we specify the texture properties. If we did not have a central funnel point like egg-palettize, then every different egg file could specify a different property for these common textures. So if we had floor.rgb in one model and it said, I want this to be mip-mapped, repeat, maybe anisotropic filter degree 3, and we had the same floor.rgb in another model file, and it says, well, just use bilinear filtering and clamp it. Well, what are we going to do at runtime? And in practice, it would probably just be whichever one got loaded first or whichever one got loaded last. I don't know. It's a little chaotic. With egg-palettize, we can specify in the textures.txa on a per texture basis whether we want it to be mip-mapped or filtered at all or anisotropic filtering. We can specify all those parameters on a per texture basis, or even overall if we just want to globally specify on a group of textures by name. And that's kind of handy. That makes it much easier to deal with invariant problems with models. You don't have to open up each model file and change a texture property and save it out again. You just change it one place. We can also scale the textures easily by editing the textures.txa. We can specify the percentage size that we want to scale it to. We can specify a fixed size for each particular texture. And we can change that on the fly, as I mentioned earlier. Pretty handy, and it's a nice place to centralize all that too. And this allows the artist to paint the textures as big as they like, and then we can scale it as needs be for the particular limitations of our hardware, which is has a lot of advantages, because if maybe we decide we want to do some pre-rendered stuff, we want to go ahead and bloat all the textures up to really big again. Well, we got the textures really big in principle, so we just have to take out all the scaling in egg-palettize, or not even use egg-palettize, and run it through the process, and we can load up some nice pre-rendered stuff. In practice, we never really do that, but we could if we wanted to.
We sometimes do it for marketing renders.
Okay, great. I'm glad to know we do it. Oh, and one more thing. I mentioned briefly in passing, egg-palettize will allow you to group textures. You can specify a relationship in egg-palettize, and I'll get to the mechanics of this. But fundamentally, you still want to put textures in groups. I mentioned when the artist does this on a per model basis, and that's often a pretty decent way to group things. But sometimes you want to do a higher level grouping. You want to do all the textures in one particular scene, for instance. You know that there's a bunch of like pigs and ducks and chickens and whatever that happen to live in this farmyard scene, and you want to put them all in the same palette group so they can all share the same textures. In egg-palettize, you can specify that all those different models happen to be in the same group together, and you should put those textures onto the same palettes whenever possible. Furthermore, that barnyard scene might be part of one particular island which has several other textures in common. So you could say that this barnyard scene and that forest scene happens to be together on the same island. They should be grouped together. And so any textures that happen to be common between the barnyard and the island can be put on a common texture that's common to both of those. And the hierarchy goes further up. Egg-palettize can support hierarchies of arbitrary depth in this way. And what it does is when you specify that two groups have a common hierarchy, common parenting, if the same texture ends up on both of those groups, then it will automatically put it into the common parent. If you specify the two groups don't have a common parent and there's no common relationship, then egg-palettize will replicate that texture into both groups, which sometimes is what you want. If you never intend to show the barnyard scene and the forest scene in the same time, and they're not even close to each other in the game, then yeah, go ahead and replicate that texture, because that way we don't have to load all those other palettes for the forest just because this one palette happens to appear in the barnyard also. But the ability to group all these things hierarchically and change our minds as we reorder the game. For instance, suddenly we decide, oh, we don't want this island to have a forest at all. It's just barns. Then great, we can just break that hierarchy, and egg-palettize poof rearranges everything, and all is nice and good theoretically. It never ever goes wrong.
Definitely not.
Finally, one other thing that egg-palettize does, which is a nice thing, is it provides one final point to ask: how are we doing in texture memory? How many textures have we got? How big are they? How much did we reduce them? How many different groups have we got? How much texture memory is black pixels that aren't being used? egg-palettize can tell you all that. So that's a nice place to do, because egg-palettize is the only tool that knows about all the textures going to be in the game everywhere. It's kind of a nuisance that it does know about all that stuff, because it makes it really hard and big and complicated. But since it does, it's easy to ask that kind of
Yeah, I
question.
think we're up to above version 1100 now of the textures TXA file.
Yeah. That's nice.
It gets out of it a lot.
That's impressive. Okay. So far, so good? All right. I've been talking about that textures.txa file. That is a single text file, which is the primary input to egg-palettize. It's not too hard to open it up, and you can look at it. If you do, you'll see lots of lines. The top of it has a bunch of commands. You know, command this, blah, 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 you know, group, or it says, I think it says, like, oh, who knows, blend this, blend that. There's a bunch of commands, nobody knows what they do. Doesn't matter. There's a bunch of commands at the top that are just the parameters to egg-palettize. And in fact, let me point this out. You can always find out what the various options are in textures.txa. By the way, note the spelling of palletize, 1 L, 2 T's. Egg-palettize dash capital H. Tells you, gives you pages and pages of stuff about what goes into a textures.txa file. So it'll tell you all about all the various different colon commands that you find at the top of the textures.txa file if you really want to know what they're doing. Anyway, underneath all the parameters that are controlling the textures.txa, and this is controlling things like the parameter, the file type that we're writing out, the number of times the texture is allowed to repeat, the size of the palettes. These are all the parameters that tune egg-palettize overall. Underneath that, we set up the groups. And basically a group is just colon group and then whatever name you like. And bam, I've defined the group name Fubi. There's some other options. You can specify the directory that group Fubi lives in, and that can often it's the same name. In our environment, it's a phase name, phase 1 for instance, whatever. It would never be phase 1, let's call it phase 10, who knows. And you can also specify that Fubi is hierarchically a child of some other group by saying on bar or whatever, if bar is some other group you've already defined. But the key thing is group Fubi. You just define a group Fubi, and that's basically a palette. And then down here you can say wall.egg, suppose you happen to have a wall.egg, colon Fubi. I've just assigned wall.egg, and that means all the textures in wall.egg are now officially assigned to this palette. And if that's the only reference to these textures anywhere in all the egg files that egg-palettize ever processes, those textures will be copied into a palette called Fubi. And I can do this. In fact, we could do w_egg, for instance. If I knew that all my w textures, all my w egg files happen to be the same thing, I wanted to put them all in the same group, I could do that. And the other thing that we can list in the textures.txa file is the textures. And this is what you see most of the bulk of the textures.txa file is. So here we can see bricks.rgb. And again, this is the extension that doesn't matter. This is actually ignored. And we could just say bricks. That would work just as well. The only extension that matters at all in the textures.txa is .egg. Bricks colon, and the most common thing you see here is a size. You could put 100% if you didn't want to scale it. You could put 50%, which means scale it by 50% in both dimensions. Most often we tend to put just a fixed size. We want to make it, 32 by 32, 32 space 32. And then there's just a lot of keywords after here. And the most common keyword you see over and over is omit. That means, of course, do not put bricks on a palette. Just leave it as a separate texture, which you'd want to do if you want to do a set texture on it or something like that. You don't have to do it for repeating textures because egg-palettize can figure that out by itself. In fact, you probably shouldn't. In fact, in general, try to avoid using omit unless there's a real good reason to it. Let's see. There's a few other interesting keywords. Here's where you can put your filters like mip-map and RGBA means you want it to be a 4-channel image. You can put RGB if you want it to be force it to be a 3-channel image. And you can do egg-palettize -H and tell you more about those keywords. This is the key thing here is we put the size. And again, we could do just star. Sometimes we do this at the very end of a textures.txa file. We might do star 50%. So the way that the file is scanned is when it reads a texture, it just starts scanning a list of lines, and the first line it finds that matches that texture, that's the one that sticks. So if you put a star at the end, that's going to match every texture that wasn't matched by a rule up here. So anything that falls through the list we didn't actually mention, let's go ahead and scale it by 50% in both dimensions.
In Pirates, we scale it to 1% to make it really obvious when you go into something listed.
Not a bad idea.
Can we like color it green or something?
Magenta.
Yeah, we could add some feature to egg-palettize where you just automatically throw out any textures that aren't mentioned here or something like that, or yell at them, color them stupid colors. But the 1% scale is not a bad idea. There is an option to egg-palettize to ask it what textures weren't mentioned, and it causes surprises. And we used to have a policy where we'd go through and look at all the surprises every day and see what they are, and I don't know if that still happens.
Assad does it.
Assad, good for you.
Once in a while I do that.
Yeah, the management of this whole thing does get a little overbearing sometimes, especially when you have thousands of textures.
We do.
Yeah.
2,700 last I checked.
2,700, that's a good list. On the other hand, that's 2,700 textures we don't have to load individually. That makes me happy. So, let's see. The whole process, when egg-palettize run, is integrated with our build system. in particular with the make system that we build with ppremake. It doesn't have to be. Egg-palettize can be run standalone, and some of the people outside of the VR Studio environment do it that way. There's a bunch of command line options to egg-palettize, and by the way, egg-palettize -lowercase h tells you all the command line options that you can do to egg-palettize, and there's quite a few of them. When you're using the ppremake system to build your models, you don't have to know most of the command line options to egg-palettize. There's just a few handy things you do want to know. In particular, make install will generally do the right thing, at least it tries to. And the other big one is make optpal. Mostly the only person in this room who's doing optpal is probably Dickinson, who does this when he does the publish. Make optpal. Oh, and Jason's here also. He gets to do it.
So do Assad and I.
Good for you. Yeah, so right, if you're doing optimization, performance tests, and things like that, you want to do egg optpal. When you make install, what egg-palettize does is going to run through the make script. Initially, egg-palettize knows nothing about the egg files or the textures, of course. It starts off with a clean slate, assuming you checked out your tree from scratch and you got nothing. So when you do make install, it's going to have to visit each egg file one at a time and run it through egg-palettize. As it visits each egg file, it discovers the textures that that egg file uses and starts adding them into its group of palettes. So it starts off with a black image. It's whatever big it is, 1024 by 1024, whatever it is. And it comes across an egg file that says it wants to be in this group. So it creates a black image, we know the name freebie or whatever, and starts putting the textures from that egg file in that group. First come, first sit. Then it goes along a little bit later and finds another texture, another egg file that wants to be in the same group, so it's going to put its textures in there. Yeah, that won't work. And then, here's a really big one if it's down here. And of course, it's going to leave some packing problems because now there's a big hole up here, and it's kind of sad about that. And maybe it comes along with another egg file and discovers, oh, here's a texture that this was used by the same egg file, but now it's being repeated twice, and so I have to stamp it out twice. And so I need to have two copies. Oh, I can't do that, so I got to move this texture and put it down here, maybe, so I can stamp it out twice. So that leaves a hole here, which maybe will get filled in later with smaller textures, and maybe it won't. But basically, as it's going to process each egg file and discover new textures that need to be put into the palette. And it's going to put them in a non-optimal place in the palette because it's doing the best it can. Eventually, it's going to reach the end of the models tree, sometime Thursday. It's going to reach the end of the models tree. And it's going to have touched every single egg file in the tree and knows about all the textures now. Now it knows enough information to put the textures optimally. And that's what make optpal does. With egg optpal, it looks at the texture information for all the textures it has. It basically rebuilds all the palettes, starting from ground zero, now knowing what it knows. And it can say, okay, well first, I'm going to start with this big texture up here in the corner, and then I'm going to put this repeating texture over here, because it'll fit there, and then I'll put these little fiddly bits over here, and it does a much better job packing. And in fact, it may come to the end of the day, says, okay, after I filled this palette, I only used up half the space. Great. So now it's only a 512 by 1024 texture. They can do that with make optpal. So that's pretty groovy. But of course, optpal is a fairly expensive operation. It has to process the tree entirely once to read every single texture, and then process it again to rebuild all the egg files, and then has to reconvert all the BAM files to match the new egg files that it's generated. Which is why we typically do it as part of the publish process, but not as part of the dev environment.
How long does it take?
Till Friday.
Yeah.
It takes about 2 hours.
It's a few hours.
A couple hours.
Yeah.
Like 4 pilots.
Yeah, I know
It's not
about
maybe.
Yeah, that's true. Make optpal is not quite so bad as actually rebuilding all the BAM files, or having to rerun
Yeah,
and
I
and
was
everything.
saying the whole thing.
Yeah.
The whole
No,
tree takes
a while.
Toontown takes probably 2 days or so.
Yeah.
It's stupid.
It will be faster now, but still.
It can take any from hours to days, depending on the license server and the network, the bandwidth, and things like that.
And you can leave it alone, something happens. Like sometimes it will lose connection to the license server, and because it calls it every single time for every pass. So it'll just go, whoop, sorry, and just pauses.
Yeah.
And you come back and go, oh. I thought you were done. You've only gone 20 minutes.
Yeah. Or worse, it'll
Just
try to keep
start
going
over.
and keep confused when things aren't built when it's expecting them to be built.
So it needs babysitting.
So hooray for DRM, because that's saving us, right?
Yay.
Yeah, okay. What's that?
What is the?
When we run Maya to egg, or
Oh, got it.
soft to egg, we have to contact the license server to get the Maya license. So yeah, for every model that we have to convert out of Maya, that's another contact to the license server. It's unfortunate.
Luckily, though, with Optical, though, it doesn't have to do with Maya conversions again. You can just start with
Right.
egg files and go from there.
Right. Okay.
So I got a question for you, Dave.
Yes.
When we're publishing for Pirates, before we do an op pal, we do a make undo pal, and then
Okay.
we also remove the build/shadow pal. What does that do?
That might be a little more paranoid than we need to do. But that's basically completely scrubbing everything. So the other thing that egg-palettize does is it leaves some little files behind to keep track of a state so it can cache a state from one session to the next. In particular, it leaves textures.boo.
What does that stand for?
So in theory, we've got two binary formats in Panda. There's BAM and boo. And if you think about that, there's actually a fun.
Panda. Oh.
In principle, the explanation is that BAM stands for binary animation of models, and BAM is what we use for loading animation files and model files. And boo is binary other objects, which is anything else.
I like bamboo better.
Yeah. So boo is actually the same file format as BAM, but it doesn't store an animation or a model. So it's a boo. Anyway, inside textures.boo, and by the way, you can actually, there's a program called BAM view, BAM inspect, BAM list. I don't even remember anymore. BAM something. Shoot. Well, anyway, there's a program called BAM something. They can run on any BAM file. It tells you what's in the BAM file. You can run it on the textures.b file too. It tells you it's a textures palette file. You're looking it up for me, Chris?
I'm trying.
What's that?
BAM info?
BAM info, that's what it is. So textures.boo is just the all this the state of the world as egg-palettize is concerned. It's the list of all the egg files, all the textures that every egg file references, where it places each texture on the palette.
Bamboo, please.
It's everything that egg-palettize knows about the world. It's stored in textures.boo, and it's in binary format we don't care about, we don't really need to look at. It also, it has a bunch of egg files that it's generated. As it generates each egg file, it puts the output egg file into a pal egg directory in the same directory. So it's important that those egg files stay consistent with textures.boo because the makefile tool is the one that checks the date stamp on the egg files. And if you start mucking around with the egg files without changing the textures.boo or vice versa, then egg-palettize can get confused as to which egg files need to be rebuilt. So that's why it's not a good idea to remove textures.boo without also removing all the egg files. But since you're doing that with the make clean BAM, that's okay. Or make clean pal, I guess.
Undo pal.
Undo pal.
That's what make undo pal does, is it removes textures.boo and removes...
And then it runs make clean pal, I think.
Yeah. Yeah, then basically it makes clean pal. Make clean pal removes all these egg files. Make undo pal removes all the egg files and also removes textures.boo. The other thing that egg-palettize does is it creates the shadow pal files. And the only reason it does that is as an optimization because we're writing out lossy JPEG files for palette images. As egg-palettize goes, remember it's reading in the palette images, adding in a texture to it, and writing it back out again. Now remember, this is something you don't want to do over and over again on a JPEG file. So for that purpose, and only because we have that, we have the shadow pal directory, which is where it stores lossless copies of the same palette images. So it actually reads in the shadow pal version, writes that out again, and then writes out the JPEG too. If we were writing out lossless images for both the alpha and the color images, we wouldn't need the shadow pal directory. There's no reason really to delete the shadow pal directory unless you believe, well, no, you might as well. If you're deleting all this other stuff, you might as well delete the shadow pal because who knows what corrupt is in there. But in general, assuming there aren't any bugs, you shouldn't need to do that. It's designed so that make Optical is sufficient. But there are bugs. So depending on how paranoid you want to be, you can delete all that stuff every time. Or
Will
not.
it make things take longer if you delete the shadow pal directory?
Yeah, because it has to rebuild all the shadow pals. Yeah. In fact, well, you could, if you don't delete the textures.do, and you just delete the shadow pal directory, and then you do make install, you will see egg-palettize recreate all the shadow pal textures exactly once, because it knows within the textures.do which texture fed each shadow pal file. So it goes and opens all those textures, reads them, and rewrites the shadow pal directory. If you also delete textures.do and remove all the pal.egg files, then it's going to have to reprocess all the egg files and figure that out again. Okay. Let's see. When we run in the dev environment, we typically run with our pre-built models that get built by the build server. Or if we're industrious, we have our own models tree and we just do make install on that. By default, when we just run make install or we let the build server run make install, we're running in a mode called omit all, which is a recent mode we added to Palletize, egg-palettize, where basically it's going to respect the textures.txa file and look at the rescaling and everything and all these filter properties, but it's going to pretend that every texture has an omit flag on it. And that just means it builds no palettes at all and just stores a bunch of loose textures. The reason we do that is just because it makes the art pipeline so much easier. We get a new model, we don't have to rebuild a bunch of palettes. Getting a new model is not going to invalidate any old palettes. It's pretty clean. Also makes it easier to check in a file directly into the tree and not wait for the build server short-circuit the whole process, because again, we don't have to worry about invalidating something that the build server is also doing. So it's pretty convenient. It did save a lot of time when we started doing that, but it does have an unfortunate side effect, which is that in development, all of our textures are omitted. So we don't notice mistakes when we do a set texture, for instance, which we're not allowed to do on a texture that goes in the palette. Remember, when you do set texture on a palette texture, it's not going to work. But if your texture is omitted because you're running in omit all, looks fine. You had no idea that you just did something wrong until
Jason comes and yells at you.
Yeah, Jason comes and yells at you, or Dickinson will come beat you up. It happens. Fortunately, when this does happen, it's not too difficult to fix it. You go back, find the offending texture, and put an omit on it. But it does mean that there's a little bit of a disconnect there. And also, you might, if you're not thinking about it, you might inadvertently create too much dependency on omit. Whereas if you designed your game better, maybe you wouldn't need to omit this texture because you're thinking about the palettes. Well, pros and cons.
Also from the final publishes, don't ever put textures inside of the source trees for Panda or for Pirates or Toontown. It's tempting to do that for prototyping, but in the end of the day, they'll get filtered out for publishes. So like if you decide to make a texture on your own computer with Paint and then you put it in your directory, everything will seem fine, but when you publish, it won't show up.
When you
adding directories, adding textures without CVS community?
Just for interns, it's tempting. I think we did it when we first got here. We were
Yeah, in the code tree,
textures.
not even in the model.
Oh, putting
No,
textures in the code tree. Oh, yeah,
Yeah.
yeah. Don't do that.
For
Nobody tells you not to do it.
Don't use MS
Oops, industrious.
Yeah. Right, we have.
Artists will beat you up and use MS Paint. Do their job for them.
It is part of our design as a studio to have a code tree and a model tree, and they are completely disconnected. And that is by design. So if you have models, they belong in the model tree, and you have code, it belongs in the code tree. And you can't mix and match. It's a good point. Let's see. Oh, I had a juicy point to talk about, and I lost it. Curses. One more thing to talk about, make Optical. Once you've made an Optical pass, then, as I pointed out, it will optimize your palettes. If you then make install on top of that, it will try to do a good job of packing things in without damaging the optimization that's already done. But as you do more and more make installs and model changes come in, it'll get less and less optimal. At some point, you want to make another make Optical. Downside to making another make Optical call is that it's going to maybe touch a lot of palettes and change a lot of pixels around. Which is not a real big deal, except that suddenly you're downloading a lot more data than you would have been. Because if we change the size of this one texture by a few pixels, and suddenly it slides over here, then these textures slide over a little bit, and these textures slide over a little bit, and suddenly we got all these pixels just changed for not a real good reason. That means the whole JPEG image is now completely different. So we had to download this whole big JPEG image. And we touched every palette because we did the make Optical. Now we're downloading all the JPEGs all over again. All the band files because all the UVs changed. And yeah, okay. So there's a trade-off between optimizing for runtime performance and optimizing for download. I'm not sure what the best balance point is. Nowadays, bandwidth is cheap, even for the home client, so maybe it's not such a big deal to make Optical every time. There was a day that we had to be really cautious about that. Let's see, there's a few other make commands that are handy. I mentioned make undo pal. Undo pal, we do it more often than I'd like to say that we needed to, but we do it because there are bugs in egg-palettize. Egg-palettize sometimes gets in a funky state. In particular, one of the things it does badly is it tries to optimize the textures. If it sees that the texture is a grayscale texture, it notes that in its textures.bu file. Hey, this is a grayscale texture. So if you start out with a grayscale texture and then later the texture suddenly becomes color, it forgets that and thinks it's grayscale from then on. And if that happens, well, one thing you can do is you can put RGB or RGBA in the textures.txa and force that point and say, yeah, no, I know you think it's grayscale, really I want it to be 4-channel or 3-channel, whatever. Or you can just make undo pal and figure it out the next time around. Sometimes, I don't know, egg-palettize just seems to get his knickers in a knot. And it's a big and complicated program. I tried, honestly, I tried to fix it. But I've got other things to do too, so it's got some bugs. We just love it. It's so cute. Every once in a while you make undo pal and it's all good. Let's see. Make pi.text or just make pi. Very similar. Make pi.text creates a pi.text file in the root of the models tree, which contains all sorts of interesting palletization information. It basically lists all the palettes it's created, all the textures that went into it, where all the textures went, how big the textures are, lists all the surprises, the textures that were unnamed in the textures.txa file. It's a very handy thing for analyzing what's going on with egg-palettize. And this is in fact the tool that Gato has, Gato's tool for doing artist presentation of the palettes, parses the pi.text file to get all that texture information. It's just a text file. It's pretty easy to read. It has several different groups of factual information. It's useful for researching problems and just what's going on. But we've also got make pal stats, pal-stats. And this just reports total information about texture memory used, size of palettes, number of textures, things like that. Breaks it down by group and by hierarchy and things like that. The texture memory that it reports is an estimate. It's not necessarily accurate because texture memory varies according to the nature of the graphics card and what it can do. It doesn't account for texture compression at all, but it's a good rule of thumb. By the way, I mentioned in the development environment we build in the omit pal rule most of the time. In the case of pirates, of course, many of you know that we also have a Palletize tree. If you don't know, you can do this. You can just go to your PE models tree and CVS up-r palletized. The name of the branch is palletized. And the same build server is building both the development flavor, everything's emitted branch, and also a Palletize branch, which is basically Optical. And that's pretty handy for doing quick performance tuning. We don't do that for Toontown. Really hasn't been an issue for Toontown because Toontown's already done. But we were doing a lot of performance tuning on Pirates a while back, and we really needed to have that Palletize build. It's still handy.
It can be useful for your dev environment too if you're finding your graphics card can't support all the emitted textures.
Yeah, that's a good point. If you had bad performance on your graphics card for various reasons, go ahead and use a Palletize build. One thing I've noticed for quirk of CVS is that when you update on the Palletize branch, it's much slower than if you update on the main trunk. Sorry. That's just CVS for you. Let's see.
Is that because it's updating to a tag and not to the head?
Yeah, and it's updating to a tag which is, as far as CVS is concerned, far removed from the head, because back in March of 2006, I don't know when we made that branch, we forked all these textures off, and so there's one branch back here for Palletize and one branch back here for the main trunk. And I don't know what CVS is doing back there, but it might be consolidating a lot of diffs to create the Palletize branch. I don't know. Whatever it's doing, it takes a long time.
Those textures were checked in as binary files. It doesn't store divs.
That's
right?
true. In theory, it doesn't.
So maybe they weren't checked in correctly.
If it were, I think we'd be sad.
Yeah, they'd not be working if they
Yeah.
weren't checked in binary.
I don't know.
We can try to diff them.
Yeah.
I want diff them.
Oh my goodness.
Yeah, I don't know what it's doing. Whatever it's doing something bad.
Not so much.
Given that we don't, well, I guess we do need history on Palletize, but would it be worth it at some point to cut that branch off?
Yeah, at some point we might just prune the whole tree and start over. I'm not sure. I can still update my Palletize branch in 20 minutes or so. It takes me 5 minutes to update the main trunk. It depends, I guess. It might be worth looking into. It hasn't really bothered us yet enough to do that. We're getting down to the nitty-gritty. There's a let's see. Egg-palettize, when it groups things into a palette, it has to group textures by similar properties, so that if a texture has a mip-map or its alpha texture or its grayscale texture, it has to group all the grayscale textures together, and it has to group all the alpha textures together, it has to group all the mip-map textures together, for obvious reasons, because it's becoming one texture. So one texture cannot have only one properties. The trick that egg-palettize uses to differentiate these, if you have just one palette named Phoebe and you have multiple different kinds of textures going into that, is it just appends characters to the end of the file name. And you see these funny names in your palette. So you might see something like 4AMLA.RGB or something like that. This is just characters that egg-palettize has tacked on. If you really wanted to know, the 4 means the number of channels it's got in the image. The A is referring to the mode of the format of the texture. This A means it's a RGBA texture. There are other modes. M is the linear, is the mip-map. In this case, this is the min filter type, and the next letter is a mag filter. So this is mip-map linear, and this is linear mag filter, which are the two different filter modes for the texture. And A at the end would mean this is the alpha channel as opposed to the color channel of the image. And there might be a few other things that it tacks on from time to time too. Mostly we don't have to think about that. But if you're wondering what those funny letters are, that's what that's for. And if it tries to put more textures onto the Phoebe group than will fit according to our palette size, it'll create another Phoebe. So it'll be Phoebe 1 and Phoebe 2. And if we haven't grouped it any more specifically than that, it'll just group them arbitrarily by size. If it starts to split things arbitrarily like this, it might be worthwhile to take a look at where it's putting the textures and do a little by hand splitting. Because if we can group them for optimal purposes, it's best to have everything that's going to be on one model have the same palette, because that gives us the greatest chance for collapsing vertices together. So if you're doing a lot of painstaking optimization, Assad did a lot of this work. You look at the palettes it's producing, you see where the models are going, and you try to group up the models into sensible groups so that each model has about one palette. Which comes about full circle to where I started with the artist doing the palettes, which each model has about one palette. Now we're doing this a lot of hard work and we get the same result, but
it's much cooler.
It is much cooler, yeah, that's right. And theoretically it's also more dynamic, so we can change our minds, and we have frequently changed our minds about this. So probably it's a net win at the end of the day.
Yeah, one thing that helps over this whole process is if the initially, I mean, our artists did not even know that their textures are being resized to something much smaller. And they, when they make their models, they were like, oh, happy, everything looks good. But in game, it's looking really bad.
Right.
So it's pretty handy that both the artist and the programmer, they actually look at it together. Like, hey, this is the palette that is coming out and going in the game. So the artist can look at those palettes and say, oh, I see, so what is happening? So maybe that particular texture, even though it's reduced so much, they can go into the model and see like, oh, okay, what can I do better to make these pixels show up in the game?
And they can design for that target.
Yes, we are entering a new world of artist and programmer camaraderie.
So that really helps, them knowing what goes on in this process.
Yeah. So yeah, good lesson learned. Share the palettes with the artists and let them take a hand of it. Let's see. Oh, there's one other clever little trick that egg-palettize can do. Sometimes, if a texture, I mentioned earlier that a texture can only be repeated if it can be palletized if it repeats only a certain number of times. But what if you got a texture that repeats many thousands of times across a bunch of vertices? Well, if it happens that you have a lot of vertices and not just one polygon that with multiple stretches, but maybe you're breaking up your polygon so that, in fact, every texture happens to correspond more or less to a polygon in your mesh. Well, egg-palettize can actually recognize that and can actually split up this mesh into lots of separate polygons by replicating the vertices within it. It still is one mesh,